Hey guys, we're back. It's Dr. D. We're working through an introduction to statistics. Right now, the section one is descriptive statistics, and we've looked at frequency tables and bar charts and pie charts. But all the stuff we've looked at so far has been related to categorical data. Right? We had an example where we had a taco truck. And we wanted to see, what percentage of people chose chicken versus tofu or beef or what have you, fish. Whoa, sorry about that. So we wanted to see that, and we were able to do that. I'd like to talk a little bit about frequency tables when we have quantitative data. It's a little bit trickier with quantitative data, right? So the way a frequency table works is we have categories, and they occur with some frequency, right? How often, how many times. With categorical data, this is really easy, right? It's easy when you already have the categories to know what categories to use. With quantitative data, we have to make a decision. And that decision is not always straightforward. The decision is this. First, we have to decide which categories. What that turns into is, how many categories. The second is how big are the categories. Usually we want them to be of even size. So how big are the categories? And is that it? Oh, and then where are the edges? Right, because quantitative data, it's a bunch of numbers, and you got to decide where the cut points are. And so just to give you some vernacular, usually for quantitative data, we call these bins. It's hard. So these categories are bins. How big are they is going to be the bin width. And then the edges are called cut points. And so that's just some vernacular vocab kind of. That's how we talk about it. So it's not totally easy to do this, but people have been doing it for a really long time, so you don't have to reinvent the wheel. Usually the number of categories is given by k, so we're going to have k different categories, and figuring out how many to use, well, usually it's going to be somewhere between 5 and 20. The more data, the more bins we might want to use, right? So if you have a lot of data, you might want more bins. If you have very little data, you don't want to use so many bins. If you use too many bins, like what if k was equal to the number of values you have, right? Well, then each one gets its own bin, usually, right? And there'll be a lot of empty bins, maybe. But that doesn't actually help you at all, right? The point of categorizing things is to kind of abstract away some of the individual differences so that you can kind of get at the underlying similarities. So k equals n, this is bad. Alternatively, what if k equaled like 2? Well, then you have like one bin right here, and that's it, right? That's your entire, if you did a bar chart of it, that's what it would look like. Like, that's not real useful either, because then you have no resolution, you lose all detail. So this is also bad. Anywhere in the middle is going to be better than those extremes, but we can do better than that. There's a rule of thumb here, and I'm going to translate the rule of thumb into a kind of easy thing to do. If you don't know, usually it uses logarithms. If you're not familiar with logarithms, you can do this. What you do is you take your sample size, take n, you divide it by 2, and then if what you have, if the result is greater than 0.7, do it again. And how many times you go through this loop, that's how many bins you have. For example, let's say n was, what's an easy one to do? 128. Okay, how many bins do we want? Well, we divide by 2 once, we get 64. Right? Divided by 1 and 2 again, we get 32. Divide by 2 again, we get 16. Divide by 2 again, we get 8. Divide by 2 again, we get 4. Divide by 2 again, we get 2. Divide by 2 again, we get 1. Divide by 2 again, we get 0.5. Okay, now we're less than 0, sorry, this should be less than. Our result is less than 0.7. Big mistake. Okay, so it took us 8 times to get there, so we're going to have 8 bins. What if instead we had n equals 10? Or I guess we'd use 10. N equals 10. Let's make it n equals 20. 10 is not much data. Divided by 2 once, you get 10. Twice, you get 5. 3 times, you get 2.5. 4 times, you get 1.25. 5 times, you get 0.75. And then the next one is going to put us at 0.375, which is lower. So this would give us k equals 6 bins. Okay, so that a good rule of thumb. That'll help you figure out how many bins. Clearly, if n gets larger, you're going to have more bins, but it's exponential growth. So that's going to be our rule of thumb. Once we do that, we're going to define a bin width. Let's look at some data, and then I'll come back to this, and we can mess around. We'll talk a little bit more, but let's look at some data that I collected. Okay, so this is the raw data. What I did was I went to weather.com, the Weather Channel website. I just looked at the map that they had, and I copied down all the numbers by hand. As far as I could tell, and I might have copied them with error, but for our purposes, that's fine. We're not actually going to be doing anything with this data. There were 96. You can count right here. It says count equals 96. Count 96. There were 96 numbers that I entered by hand. I basically started up in Seattle and worked my way down, and then down, and then down, and then down, and then down, as best I could. Okay, now this is the raw data. I don't want to mess with this, so I'm going to copy and paste it into a new sheet. Okay, this is the data that I have to work with. Okay, I want to know how many bins there are. Well, I know that there are 96, so I have n is 96. If I divide this by 2, I get 48. If I do it again, I get 24, then 12, then 6, then 3, then 1.5, then 0.75. Now I'm less than 0.7, right? So how many times did I divide it? 1, 2, 3, 4, 5, 6, 7, 8 times. So I'm going to be using k equals 8. K equals 8. Okay, so once we know how many bins we have, then we can roughly decide how big each bin should be, right? Because if we have the number of bins, well, we want to be able to fit all of the data into those bins, right? So what that means is we want, between the highest number and the lowest number, we want to have the number of bins fit there, so that the smallest thing fits in the smallest bin on this side, the largest thing fits in the largest bin on this side, and then in between we have all the other stuff. So the way that we do that is it's a pretty simple math. The bin width, let me change my color again. The bin width is going to be the range divided by the number of bins. The range is a term we haven't talked about yet, but the range is pretty easy. The range is the largest number, the largest value, minus the smallest value. Now, if you have 96 numbers and they're not in order, this can be kind of hard to figure out. But we can sort them pretty easily in Excel. So go back to our data, select this whole thing, click Data, Sort, smallest to largest, and there we go. So our smallest value is 44, and if we scroll down, our largest value is 85. So 44 to 85. So our range is going to be 85 minus 44. That's 41. We know we have 8 bins, so our bin width is going to be 41 divided by 8. That's 5.2. Okay, now for convenience we can round this. The way that I've decided to do this, and this is often subjective, is that I'm going to use 5 as my bin width, but that means that there's going to be one side that I have to just throw some extra stuff in, right? Because essentially I'm only going to be able to capture a distance of 40, like this. That's okay. What I'm going to do is I'm just going to throw the bottom one, because I looked at the data and I see that at the very bottom 44 is kind of an outlier, and so I'm just going to throw that into a bin at the bottom. Okay, so I'm going to delete this stuff here. I don't need it anymore. And I have, oops, maybe n might be useful to keep. So n, k, throw a range in here. You can calculate a range here just to double check. Doesn't have a range function. Good enough. So it's going to be this one minus this one, 41. So that gives us our bin width. I'll do round this divided by this. Oops. I never really understand round function. There we go. 5. Cool. So our bin width is 5. Now I have to decide to cut it up. 44 seems to be a low-end outlier, and so what I would really like to do is to make my bins look like this. 44 to 50 is my smallest one, and then go up in 5-degree increments from there. 51 to 55, 56 to 60, 61 to 65, 66 to 70, 6, 7, 8, 9, 0, 71 to 75, 76 to 80, 81 to 85. And that should get me all the way to the top. It does. Cool. Okay, so now I have all my bins. My bins those are my cut points, and I kind of decided that somewhat arbitrarily, except that you'll see that these bins are almost all 5. This one is extra big, but the rest of them all kind of fall into what seem like obvious choices. Okay, now the way to do this part is a little bit tricky, because what I want to do is I want to count to see if the stuff is in here. There are 2 ways to do this. One is with a pivot table, okay, and I'll show you how to do that first. Let me make 2 copies of this. So I'll do one with pivot table, and I'll do one without. So I can select my data, go to Insert, Table, Pivot Table. Pivot Table. There we go. And I want to do it in this worksheet. I'm going to start it at I1. Okay. So there's a pivot table here that is going to be using the information that I just gave it from that sequence. What I want to do now is I want my row labels to be the current temperature. And then what I want, since I'm building a frequency table, that's what I'm going to do now. I'm trying to build a frequency table. I want to put these values down here. Right now that's going to give me the sum. And I don't actually want the sum. Right? What I want is the count. So if you click on this sum thing, go to value field settings and say you want the count, you'll switch that to count. The problem is right now, this just gives it to you 1 by 1, right? So per degree. That's not really what I want. What I want is I want to group these. So the way to do that is to click group, starting at, let's start at 40 or 51 and go by 5s. Does that work? That's not exactly how to get it to work. Oh, start at 46. Start at 46. That's what I meant to do. Group start at 46. There you go. And that should give you the same distribution, right? 1, 8, 5, 9, 20, 21, 6. So that's a frequency distribution table. Now I don't particularly like that. The reason I don't like that is that I like to be able to work with formulas, but it totally works. And people who are more comfortable with pivot tables, they swear by them. I'm not so comfortable with it because I'm used to messing with formulas, and I like formulas. So I'm going to show you how to do it with formulas. What you can do is you can use Countif. So let's use our Countif function. We use this for the beef tacos, right? I want to count this range, right? These are my values. You can include the header if you want. Oh wait, and we want it to. So that's my Countif. That's my range, and then I also want the criteria. What I want to do now is I want to choose anything that's larger than something, right, or in between these 2 values. Because this is the small end, I can choose things that are less than or equal to 50, right? Less than or equal to 50. And that'll work. The problem, as I said before, is that I don't really want to be hard coding this in here, like putting a 50 in here. So what I'm going to do is I'm going to create another column here, which I'll call bin tops, right? The top of this bin is 50. So now when I modify this, I can change this. The problem here is if you go like that, does that work really? Oh, that's the problem. When you copy and paste it, it won't adjust. So you can put less than or equal to F2 in there, but it won't adjust. The right way to do that is to modify it slightly. You put an ampersand and then put F2. And the ampersand is how Excel knows that you want to take 2 pieces of text and stick them together. For some reason, Excel uses text for its criteria, and so this is the only way you can solve that. Okay, now when you copy and paste it, it will adjust it. I made a few mistakes. One is I didn't put absolute references in my range. I want to do that. The other is I didn't account for a problem here. That problem is that if you count all the ones that are less than or equal to 55, there's 9 of them. But what I want is just the ones that are between 51 and 55. Okay, so this shouldn't say 9, this should say 8. right? That's, if you look at a pivot table, that's what it said here. So we want this to be 8. The way to do that is to subtract what we already counted, right? Because what was in there was just everything less than 55. We want to subtract what we already counted. Now that's almost right, but there's still a little bit of a problem. If you want to see the formula, it's still right here. The problem is when we copy and paste it, it's going to give us, well, first it's going to give us a big problem there. But it's still going to give us the wrong answer because now it's subtracting just this 8. It's not subtracting the 1. So what we really want to do is we want to subtract the value of all the previous ones that we've counted. And that's easy to do, as it turns out. Instead of subtracting h2, we can subtract the sum of h2 to h2, which right now is just one number, right? But if we modify the first one to make it absolute, then when we copy and paste it, you can see that it has expanded to include 2 things. When we copy and paste it again, first of all, we need this to be 65. You can see that it has expanded to include all 3, expanded to include all 4, and so on and so forth. You can look at the pivot table, see that they come up with the same answer. We can add a total here, and add a title, frequency, and there you go. Right? We have what we were hoping to have. You can make it bold, you can center these if you want, make it wider. And there you go. You have a frequency table. If you want to get it away from the bin tops, you can do that. You can copy and paste this into whatever you want. Okay, cool. There we go. Anyway, that's how you make a frequency table with quantitative data. It takes a little bit more work. The nice thing about it is that it has the formulas that we can still get access to, right? So we know exactly how they're calculated. Now to do the other stuff that we did before, relative frequencies, that's really easy. Again, we're just going to divide this by what we had before, by this down here, make it absolute, and we can copy and paste that. That's too many decimals. I don't like that many decimals. So we can real quick fuss with it. If we want it to be a percentage frequency, and those are a little bit easier to work with maybe, we can just refer to these, get it exactly the same, and then express it as a percentage instead. So all of these are going to be percentages. This gives us a lot of information, right? We have the bins, right, and we can see that, well, there's a big cluster right around here, right? Between 66 and 70 is the most common. The least common is obviously that outlying bin. And that's pretty useful. We'll be able to visualize this data pretty easily now, and I'll show you how to do that next time. Okay, thanks a lot, guys, and I'll be posting more stuff soon. If you have any questions, as always, post a comment, subscribe to my channel, like it if you like it. Thanks a lot. Bye.